Hello and welcome back. So far we have understood how to build a multiple linear regression model, and we understood the concepts of underfitting and overfitting. We found that the model is underfitted because the model is not working well on the train set itself. We have got only 62% accuracy. The R square score is 6.62. So we need to in order to fix the problem, we need to make the model the complex, because if you look at the learning curve, the data is sufficient. By 400 records, the linear regression model understood what it need to understand. But still model is not working. That means the linear regression is not complex enough in understanding the patterns inside the data. So we have to build a polynomial regression, or we need to make the model a bit complex. So before we build a polynomial regression model on this data set, let us try to understand what is polynomial regression, how we will make linear regression of a polynomial regression algorithm. Okay. So I have taken, to explain this concept, I have taken a simple data set where I have got only two columns, the input feature and the output feature, and I have separated them into x and y, so that I can build a model and show you how exactly the polynomial regression works. So we have got input feature and output feature as two columns, and if you look at the shapes of x and y, there are 100 rows and one column, 100 rows and one column. It's a synthetic data, generated data. When I try to look at the data pattern, right, as we have only one x and one y, we can do a two-dimensional plot and understand the pattern. So I have done that here. Right, the data is non-linear, right? It's a parabolic kind of a shape. If we build a model which actually goes through this data like that, right? If you build a model which actually goes through a parabolic curve, goes through the data like that, then the model, the predictions will be more accurate and the error will be less. In order to build a model like that, we have to add polynomial terms to the data set. Let us see how we will do that. So our data set is input features, right? Input, right? And output feature. So this is how the data set is, right? So we call this input feature as x, the output feature as y. If we have to, if we build a linear regression model using this x to find out the y's, you will get a straight line, maybe something like that, a straight line. So y is equal to theta 0 plus theta on x, you will get. So in order to build a polynomial regression model or a curve which goes through the data like that, right, we have to add the polynomial terms to the data set. Or in other words, you can say that there is x, there is y. If you add x square into the data set and then pass this data set to the linear regression model, right, it will actually build this hypothesis function will change like theta 0 plus theta on x plus theta to x1 x1 square or x square, right? This is a polynomial equation or a parabolic equation. When you train this model and try to input your data, the x's, into this, then you will get a line like that. Okay, so that's going to be better, because when you make predictions, the predictions are going to be on this curve, right? They are actually close to the actual values. The predictions on this curve are going to be close to the actual values. That way the error will reduce. So to make a linear regression model a polynomial regression model, you need to add the polynomial terms to the data set and then pass this data set to again the linear regression algorithm, which will actually take the hypothesis function a shape of a polynomial equation. So that is the intuition, or that's how we need to actually build a polynomial regression model. In order to add these additional terms, we have a class called polynomial features in scikit-learn. So let us try to understand how it works. This polynomial features is a class which actually adds the degree, right? The terms for the degree you have specified. So here I specified degree 2, right? So the polynomial features will actually add second degree term in the data set. How will it add? Let us see. To this polynomial features class, if you pass degree is equal to 2, what will happen is it will add n plus 2 factorial by n factorial into 2 factorial number of features. What is n here? Number of features in the data set. We have only one feature there, x, right? So 1 plus 2 factorial divided by 1 factorial into 2 factorial. Okay, that's going to be 3 factorial divided by 2 factorial. 3 factorial is 3 into 2 into 1 divided by 2 into 1. This will get cancelled and it will create 3 features. That too, when you say include bias is equal to true. In these 3 features, one feature is x0, the bias term. Second feature is x, the original the column we have in the data set. The x2 is nothing but x1 square. Okay, that's how it's going to add. This x0 is going to be 1 for all the rows. The x is the original value and x square is the squared value of x. That's how it's going to do. So the polynomial features, when you pass the d degree, it's going to create n plus d factorial by n factorial into d factorial number of features. Okay, if you say, if for the same data set, if you want to do 5th degree polynomial, you need to pass degree is equal to 5. When you pass 5, right, what will happen? There is one feature in the original data set, and we are trying to do 5th degree polynomial 1 plus 5 factorial by 1 factorial into 5 factorial. The 5 factorial. It's going to be 6 factorial by 5 factorial. It's going to be 6 features it's going to create. X square, x cube, x to the power 4, like that 6 features it will create, including bias term. Because we said bias term is equal to true. If bias term is equal to false, then it's going to do n plus d factorial by n factorial into d factorial minus 1 number of features. Right? So we have actually created the class, the object of this class, right? The polynomial features degree 2 and include bias term true. It actually created a class, and to that class we said fit and transform. When I say fit, it will understand how many features are there and it will calculate how many features it should create, how many polynomial terms it should create. As soon as we say transform, it's going to change, it's going to add those additional terms. In this x poly, you will have 3 features. One is x0, that is 1 for all the records. Second is the x, third is the x square. So it created a polynomial data set. Now when you pass this polynomial x to the linear regression algorithm and fit, the model will understand. Okay, the model will understand the pattern. And now if you see this, right, the red dots are the line it actually identified, the polynomial line, the equation it identified. The blue dots, as we see, they are actual data points. So when you try to make the error calculation, right, it's going to be less. So that's how the polynomial regression works. So I think you got the intuition of polynomial regression, and let us move on and understand more about polynomial regression in the coming session. Thank you.